Okay, folks, we're going to take a look at two types of linkage synthesis. One is when a rocker is prescribed through two positions, and we're usually told something about the crank. And then the other will be when we have position CD that moves through space. So in this case, we have a rocker through theta. We'll go ahead and give that an angle. We'll say 50 degrees. And we have a crank. We'll do the example again where it's an even time spent out and in, out and back. So what we're going to do, and I tend to draw linkages where 2 is on the left, 3 connects left and right, and 4 is on the right. So I tend to think about my rocker as far to the right as it can be. So I'll start by picking an arbitrary point in space for 04, and then an arbitrary starting position, right? So this is just putting something down, sticking a flag in the sand where we can start from. So from there, we're going to get to this 50-degree mark. But here we go, 50 degrees. And so I'm going to lightly sketch out where that second line is, right? So we have two lines that prescribe our theta 4 of 50 degrees. After that point, I have to now make a decision. We're going to set an L4. I'm going to go ahead and pick, 8 stuck in my head from class, so we'll use 8 and label B1. And label B2. And note that I chose L4 is 8 centimeters. Okay, so now we're going to connect B1 and B2, and I'm going to grab so we're going to connect B1 and B2. And somewhere on this line is O2. So if you want nice whole numbers, you would probably want to use a measurement to set O2. And if you just want to put it somewhere, or if you have some other constraints, you can set it that way. So I'll go ahead and set mine here and use 8 again and see what happens. Bad things could happen. Could be not crash off. It's okay. We'll figure it out. And so now we have O2, and at this point we're going to bisect B1, B2 and figure out how long our crank is. Okay, so just lightly sketching, my bisector here. So this is the center, and I could measure it first, but I'm used to measuring it at the end. So I'm just going to grab my radius, which is half of the line B1, B2, and draw out my crank. And then we can do all the measuring. And so here we go. This would be A2 and A1. This here is L2. This is L3, and we know L4. So let's do some measuring, and we'll check for crash off. So L2 would be 3 centimeters. L1 will measure, and I see part's not super because my pencil width is right. It's a millimeter, but it looks like 13.2. And so we're going to do our Grashof comparison. Shortest was longest compared to the two middle added together. So we'll take our 8 and 13.2 and we'll add, 3 and 13.2, and then we'll add our 8 and 11 and compare them. And so we're going to get the 16.2 compared to 8 plus 11 is 19, and this is in fact less than. Written this very awkwardly. So we have our linkage, we have it drawn out here, we have checked for Grashof, and that is this synthesis. So then we'll take a look at an alternative. And I guess one thing I want to make clear here is that we can turn two-position synthesis into rocker synthesis. I'll go through that step one more time, but I'm not going to synthesize the whole rocker after. At that point, you come back and you do this process. So let's grab two positions here. Okay, I connect the dots. I want to draw C1, C2 and D1, D2. And I'm going to bisect those. And that's true for either of these methods. For either of these methods, I'm going to start by drawing line D1, D2, and C1, C2 and bisecting them. And I would not recommend bisecting them this largely, but I've committed now. Sorry, folks, I don't have very good video editing software, so multiple takes, piecing together. It's not kind of how I tend to do this. So let me draw out my perpendicular bisector. I have to do some erasing for D. That was much, much, much too big. So I'm going to draw my perpendicular bisector and then lightly erase my guidelines, just so I am not taking up the whole page with those arcs. Okay, so at this point, I am going to extend these. So this point, we C1, C2, and D1, D2 draw to bisect, right? Now we are going to find the points of intersection of my C1, C2 bisector and my D1, D2 bisector, and that will be O4. So for a rocker, find O4 is step 3. And so here we go. I'm going to grab this line and extend it to the bottom of the page, this line, and extend it to the bottom of the page. And I have found O4. And now my rocker has to rock between position C1 and position C2. And so my very last step is usually to just set an arbitrary length here, B1. This is why I work in centimeters. It's a little over 4. Well, we're not going to do the example anyway, so that's fine. I'm just going to draw it even. So this will be B1 and B2. And now synthesize the rocker, right? So I'm going to have a linkage that goes through O4, is pinned at B1 to the coupler, but also contains D1 and C1. Okay, and so that's the idea of finding a rocker to get between these two positions. And synthesis method 2. Okay, so same first two steps. Draw C1, C2, draw D1, D2, step 1. Bisect both, step 2. And now I'm going to draw my bisectors, and I'm just going to pick O2 and O4. So let's see here. So this is for my coupler. So we draw bisector lines and then choose or set O2 and O4. However, this results in a non-Grashof linkage. So if I set this over here, and then here, I could put 04. Yeah, you know what? I'll go ahead and do that so we'll look at it. When we did it in class, I think I put 04 up here, but I'm going to set 04 along the bisector of D1, D2, and I'm going to set 02 along the bisector of C1, C2, and that will give me a linkage with L2 here connecting C1 and O2. L3 is the coupler that moves through this position requirement, and O4 here connects D1. L4 connects D1, and so this will rock back and forth from this position to this position. Okay, and so that would be the coupler method. So we end up with a crank of 7.3, a rocker or an output of 7.5, and then our coupler and our ground are both 5. And so if I was to take 5 plus 7.5 and compare it to 5 plus 7.3, it's a non-Grashof. And that's the second synthesis.